Deep in a remote cave in Wyoming, an excavation team worked under headlamps. Their tools scraped carefully across ancient bone. What they uncovered was extraordinary: the nearly complete skeleton of a dire wolf, entombed for over 50,000 years. Picture the world these predators once dominated: the Pleistocene Ice Age, a brutal landscape where giant bison herds stretched to the horizon, where woolly mammoths and American mastodons roamed freely. Packs of dire wolves moved like ghosts through the cold grasslands and forests. They were the ultimate apex predators, built to take down the largest prey on the continent. For decades, scientists believed these animals were simply oversized versions of the wolves we know. But the DNA preserved inside these remarkable remains would change that forever. What it revealed would not only rewrite the story of dire wolves, but expose an entire lost branch of Ice Age predators that no one saw coming. For over a century, dire wolves were understood as simply the larger American cousins of the grey wolf. Scientists classified them as Canis dirus, the ultimate pack-hunting carnivores of the Ice Age. These powerful predators were believed to be perfectly adapted to taking down the massive megafauna. With their robust skulls, powerful jaws, and muscular builds, they were seen as oversized versions of the wolves we know today, only built for a world of giant bison, horses, and camels. Textbooks, museum displays, and scientific papers all painted the same picture. Dire wolves were the apex pack predators of North America, ruling the cold grasslands and forests. Through strength, cooperation, and sheer size. This interpretation made perfect sense. The bones looked right. The hunting strategy appeared identical. Everything fit neatly into our understanding. And for generations of paleontologists, this remained the unquestioned truth. This model persisted for very good reasons. First, the skeletal evidence was overwhelming. Dire wolf skulls and teeth looked remarkably similar to those of grey wolves. The differences were subtle enough that experts assumed they represented variation within the same evolutionary line. Second, ancient DNA recovery from Pleistocene remains seemed nearly impossible for decades. Most dire wolf fossils came from sites where genetic material had long since degraded. Paleogeneticists focused their efforts on colder regions like Siberia and Europe, where preservation was far better. The American West appeared hopeless. Third, the simplest explanation always felt correct. Animals that looked alike, hunted the same massive prey in the same way, and lived on the same continent had to be closely related. This logical assumption was reinforced by every new fossil discovery. The model was clean, consistent, and supported by mountains of physical evidence. It was published widely and taught confidently in universities for more than 100 years. Nobody seriously questioned whether these terrible wolves might represent something far more ancient and strange. Actually, the breakthrough came from an unexpected geological accident. While thousands of dire wolf bones from the famous La Brea tar pits were beautifully preserved as skeletons, the hot asphalt environment had completely destroyed any usable DNA. The sticky tar penetrated deep into the bones, and the fluctuating heat accelerated genetic breakdown. But in certain protected caves and sediment deposits in places like Idaho, Ohio, and Wyoming, nature created perfect conditions by accident. Deep inside rock shelters and stable cave systems, the remains were shielded from extreme temperature swings and chemical damage. Dry, consistent conditions allowed tiny fragments of DNA to survive in the densest parts of teeth and ear bones for tens of thousands of years. These rare microenvironments acted like natural time capsules. In 2021, a team led by paleogeneticist Angela Perry published a groundbreaking study in the journal Nature. They achieved what most experts believed was impossible. Using advanced ancient DNA techniques, the researchers successfully sequenced 5 full dire wolf genomes from subfossil remains, ranging from 13,000 to more than 50,000 years old. These specimens came from protected cave sites across North America. More recently, in 2025, Colossal Biosciences and collaborating teams pushed the science even further, recovering higher quality genomes from samples as old as 72,000 years. These included remarkably preserved teeth and dense inner ear bones that had escaped the destructive conditions of sites like the La Brea tar pits. What they accomplished was a technical marvel, opened an entirely new window into the deep evolutionary history of Ice Age predators. The results were explosive. Dire wolves are not wolves at all. The genetic data revealed that they represent a completely separate lineage that split from all living canids roughly 5.7 million years ago. That is nearly 6 million years of independent evolution. While they evolved on the same continent and hunted the same giant prey, dire wolves developed in total isolation from the ancestors of modern North American wolves. There was zero gene flow between them for hundreds of thousands of years, despite sharing the exact same landscapes. This makes them a true ghost lineage, the last survivors of an ancient New World canid branch. Their DNA shows they were far more distant from grey wolves than grey wolves are from African wild dogs or dholes. The animals we had called the ultimate American wolves were actually something far stranger and far older than anyone had imagined. 3 things make this discovery impossible to dismiss. First, the extreme genetic distance combined with remarkable continuity across tens of thousands of years. The dire wolf genomes remained consistent from the oldest samples down to the youngest. Second, the complete lack of hybridization. Unlike almost every other member of the canid family, which readily interbreeds when ranges overlap, dire wolves show absolutely no evidence of gene flow. Third, this is a textbook example of convergent evolution at its most dramatic. Dire wolves only looked and hunted like wolves because they faced the same ecological pressures. They converged on a similar form without sharing recent ancestry. Together, these lines of genetic evidence completely rewrote our understanding of Ice Age carnivores and proved that looks can be deceiving. The dire wolf discovery is not an isolated case. It is part of a wider pattern that is now emerging across Ice Age predators. Ancient DNA studies are revealing similar hidden lineages in other megafauna carnivores. The American lion, long classified as a close relative of modern lions, actually belonged to a deeply divergent branch that split off hundreds of thousands of years ago. Saber-toothed cats like Smilodon were part of an entirely separate evolutionary lineage that had diverged from all living cats around 20 million years ago. Even the giant, short-faced bear, the largest carnivore of its time, shows evidence of convergent evolution and represents its own unique branch with no close living relatives. In each of these cases, entire ancient lineages of specialized apex predators evolved in isolation, ruled their ecosystems for hundreds of thousands of years, and ultimately disappeared. The debate around these findings is real, and I want to be honest about the tensions. Some researchers rightly note that the original sample size was limited. Newer data from 2025, colossal biosciences projects using significantly older and higher quality samples, continue to reinforce the same startling conclusions. There are still active arguments about how much weight we should give to traditional skeletal morphology compared to genetic evidence. For decades, morphology led us to one conclusion, but DNA has overturned it. And questions remain about whether any faint genetic traces of these ancient predators might still linger undetected in modern North American canids. While that possibility cannot be entirely ruled out yet, the overwhelming evidence points to complete genetic isolation and replacement. This healthy scientific tension shows exactly how our understanding of extinct predators continues to evolve. And here is what keeps me thinking about this story weeks after first reading the papers. These dire wolves were not short-lived experiments in evolution. They were dominant apex predators that successfully ruled North American ecosystems for more than 250,000 years. They hunted in powerful packs, taking down some of the largest animals to ever walk the continent. Then they vanished along with their prey in what feels like a geological instant. Their story highlights the extreme fragility of highly specialized carnivores when ecosystems collapse. When the giant herbivores disappeared, the predators had no easy path to survival. Scientists are actively searching for more ancient DNA across the continent, hoping to fill in the missing chapters. And that, honestly, is the most important part of this story. Not just the remarkable answers we have already uncovered, but the vast scale of what we still have not yet asked about these extraordinary, terrible wolves.